Buongiorno a tutti, sono Xavier Mathieu, faccio una sostituzione dell'ultimo minuto per conto del collega Florent Bougerol. Sono responsabile del ramo Duroblade, quindi la parte aziendale nostra che produce lame in ceramica e in carburo in Svizzera. Abbiamo altri due rami, come saprete, uno della strumentazione in Svezia e l'ulteriore acquistato qualche anno fa negli Stati Uniti, che è la società Capstone che produce oggi le nostre capabilities informatiche, che si chiama Data Park. Let's switch in English then. So today I will present you a statistical approach based on some process data analysis regarding the crepe blade wear modeling. This is an original work that has been studied by my colleagues 3 years ago and that we have been completing step by step. So I'm going to spend 2 minutes here just as an introduction before going faster on the other slides. Just to let you know that this database is based on almost 1,000 blades so far, 960 to be more precise, and it's considering all tissue machines worldwide. This is including obviously steel blades and high performance blades. What we call high performance blades are ceramic blades and carbides. This is including obviously Yankee that have been metallized or that are still in cast iron. And we've been considering into this analysis coatings, coating types, dosages, but also the usage of cleaning blade and more. We talk in one slide about grade and furnish. Obviously, this is a two variable analysis. We can do more. I will spend some time to talk about this. Basically, this presentation is a benchmark conclusion on blade behavior, what happens of the blade against the Yankee and the paper, and to debunk some common beliefs. It will also give some recommendations to tissue producer for an optimal setup, and obviously we will talk about slightly what is necessary to do in terms of management for this type of high performance blades under safety conditions for the Yankee dryer. So just to recap very quickly, let's start first to talk about the blade wear mechanism around creping. So as you can see on the left side, we have one steel blade and one ceramic blade. The main difference obviously is that the ceramic blades are produced with a pre-sliding angle, but they are basically the same type of bevel angle. What we have around the tip that is in contact with the Yankee, you have basically specific wear of the blade against the surface of the Yankee. This is what we call sliding wear. This is what we say, maybe for the translators, angolo di scorrimento e usura di scorrimento. The other point is basically the tip disintegration with what we call the impact wear. Typically, there are some issues around the creping position. Let's call them suboptimal blade wear. Saying that they are not correct will be wrong because there are many producers that are actually producing tissue, and depending on the type of paper, the quality of the paper, they can actually have a wider operating window than the best practices. So we call them suboptimal blade wear. Typically, what we can have is an issue regarding the quality of creping, so coarse crepe and poor crepe quality. The machine direction is in vertical here. You can have a loss of coating control that is leading to web breaks and pinholes. So typically when the blade is at the end of life, the tip is too rounded and the sliding wear is too wide to correctly control the coating. So that's indeed a consequence, just as the title is saying. And the other point is the hard coating, which is actually leading to blade vibration and shatter potential. So here it's sometimes a little bit, when we do troubleshooting in the machines, the question of the egg and the chicken. But normally this is a wrong condition that is leading to hard coating. And you will see why in the next slides. So what we've been doing is basically building a database. We've been sampling all the blade analysis that we are regularly doing on the customer side. What we do is basically, as the majority of you know, is that we use some very precise optical system to have the profile of the blades and to understand exactly the different dimensions of wear that you can see in the cross-section of the blade as for the previous slide. We obviously have been stripping off all the customers' names. It's a statistical analysis. It's not specific to countries, groups, or customers. The idea is about collecting as much as data as possible to put some spices of digital concept into this. We've been using, obviously, because the variability is high, the medium and not the average blade wear. And so this is what you see here. And we've been normalizing the wear. So basically, we always measure the wear rate out of 100 kilometers of Yankee travel or paper produced. Then we've been doing some segmentation, categorization of Yankee coating. We've fully cost-linked or what we call blended premium coating. Also, we've been taking the standard modified PIE and the basic ones. Additionally, we've been putting some process parameters to try to draw conclusions. So the first thing among all them is to understand that the blade wear is not linear with time. You don't control the Yankee surface in the same way over the time for a simple reason. It's not a linear function. The reason is that friction against the Yankee is something that is related to the volume of ceramic or steel at the tip of the blade that is removed over the time. So you understand that a two-dimension measurement is not actually linear because it's a question of 3D. Typically here you have the time of operation in one axis, and you have the sliding wear rates in microns over 100 kilometers of paper for one of the most common blade that we are providing on the market, which is called soft crepe. And this has been refined only on metallized Yankees. And still you see that the distribution is very similar to a Benford distribution. So, quick comparisons, all sliding wear rates. There's no surprise, actually, that if you look at the blade types, the steel is having definitely a higher wear rate. But there are differences, and quite significant differences, between the different types of high-performance blades that are available today on the market into BTG and not only. Typically here, you see the very average of all the high-performance blades among the market, which is probably something like 10 times less than the steel. But in the very recent years, we've been able to develop, in position 12, some blades that are basically running with almost no wear, which is helping to work in very safe conditions for the Yankee. So another point that is interesting another conclusion that is interesting to draw is the impact of grade and furnish, as I said earlier. Typically, there's no surprise that the wear rate is lower for virgin fiber kitchen towel here. There is the contribution of an excellent type of raw material, the way it's processed, and as a third point, the use of Kimene that is actually a natural lubricant for blade. The more aggressive grades, at contrary, are typically around hanks and the recycled fibers, obviously. We've been also looking at some coating add-ons around 3 different BTG blade types. The most common, as I said, is a soft crepe, but also Vantage and Vantage Plus blade. We took all of them. We've been basically comparing the sliding wear rates over the base and modifier add-on. And what we see is that there is an improving in trend for the blade wear with increased base and modifier add-on. So definitely the more you cover your Yankee, and normally the more you will get lifetime of the blade because it's wearing slightly lower. If we compare by segmentation the Yankee coating types with these 3 BTG blades, you can easily assess that basically the coating type has a big impact on the sliding wear. Typically, the fully cost-linked or blended premiums are the coatings that are helping the blade to last longer on the machine because of a lower wear rate. Just behind, you can find the standard modified PIAs, and the basic ones are slightly over, with, by the way, a very high 2 sigma value here around that typical blade. So Obviously, 1,000 blades is a pretty big database to start to investigate, but not fully efficient to draw every single conclusion. That's very far away from the principles of 4.0. 1,000 values, maybe 1 hour of production or maybe 1 day. In that case, it's 3 years of work and maybe more. So in some cases, we need to be very accurate and careful when we draw conclusions. But long story short, the blade life repays the investment in premium coating. So, what about visual appearance of coating? We've been, this one is a bit trickier because it's also including some personal considerations by human beings. For the common best practices and some recent training that has been done during the TAPI sessions around the Yankee coating, an even translucent coating layer is what we want to have, is what producers want to have. White coating is just only a contaminated surface with fiber and will, as a matter of fact, compromise the blade life. So what you have here is definitely that the lowest wear rate is on the translucent coating. The contaminated is actually just before, after this. Definitely what we don't want to have at all costs is a streaky coating because there are so much differences in cross direction that you will condition very differently your blade from position to position in cross direction. So I've been using the term of white coating. So what is a white coating? So during the sessions with TAPI, David Welsford, I've been actually showing some pictures, and this one is a pretty clear explanation and image of a white coating. You basically see this type of surface in a lot of mills around. We have to remember that there is no polymer coating at all that will dry and become white. That's only a contribution of fines that is step by step over the time sticking to the Yankee surface. And this is something that we want to avoid for the best performance of the blade and definitely for the best creping quality. So how do we do coating control if we don't want to have this? Well, there is a possibility around the mechanical area. Typically, we can, with this database, answer if we should use a cleaning blade. And the answer is clearly a yes. We've been having different cases around the globe. We've been using vibration monitoring systems to demonstrate this. We've been consolidating this data with blade lifetime, but this statistical approach is also showing the same results. Basically, what we know, we have customers working with the cleaning all the time, the cleaning blade only at blade change, the cleaning blade from time to time, and some customers running with a cleaning blade always open. Typically, we are sure with this statistical approach that using it all the time is the best approach to leverage the coating layer on the Yankee. So what type of cleaning blade is best? Any type of cleaning blade is better than none, as we saw before. The ceramic works better than steel, for sure, because the blade is conditioning very fast. And it's not a position where the majority of producers are spending a lot of time when they produce paper. They concentrate on the creping position, not necessarily on the cleaning blade. For sure, what we know from this analysis, and over the last years we've been developing some blades specifically to cleaning position, is that the BTG Safe Clean blade is the best of all for this type of application. Another point is a comparison of steel versus ceramic by Yankee surface type. So here, absolutely no strange results, definitely. Working on steel and cast iron is the most complicated situation, and the best is definitely use ceramic with metallized Yankee. So all these slides are basically a two variable analysis. Linear, non-linear, but basically two variable analysis. If we want to really put some spices of 4.0 into this, we can actually run with this database or bigger database from the time being, some multivariate non-linear modeling. And this is where basically BTG is working at the minute. We've been using this type of approach to link the process to reduce the variability of any single process data. That could be actually the quantity of fiber we put on the web. That could be a bulk, that could be softness, and we've been using the same principles of MVDA around the blade to try to have a model. And typically one of the parameters we've been using so far is the basis weight, the blade angle, add-on release, the stick out, the blade holder type, paper grade, cleaning blade usage, the coating and the base coat. And these are the data that have been extracted so far in the previous slides, and we are running at a minute on this. So using the principles of Industry 4.0 environments is actually helping us to getting out from commodity. And this is something that is interesting for both parts because producers may actually get a higher benefit from just a simple blade. As a summary and some advices, if we may, for the tissue makers, the blade wear rate is a good indicator of runnability. Obviously, this is normally used as a single KPI on site, but we are absolutely available to support you to do full benchmark comparing meal by meal in your group or to have some common informations via a full benchmark worldwide. Same thing for the crepe performance and obviously asset reliability. Run a great coating layer is basically something that is a good advice for everybody. High add-on, premium-based products, and control the wet end for a nice, shiny, translucent coating layer. Third point, we've been always promoting this. If you have metallized your Yankee, run ceramics. And finally, run a continuous cleaning blade would be something that you may evaluate on the long run if you are not already using it. And ceramic is the bait for to get the lowest sliding wear at the creping blade. But be realistic about your blade wear expectation. It's really depending on the type of furnish and paper grade. Still, be careful. Not all blades are made equal. Are not made equal. Sorry. It's not only a matter of hardness. It's not only a matter of geometry. Be careful about the blade material. Consult your supplier. The lifetime is something that is important. The better lifetime is something that is usually assessed to be very important for customers to get the maximum of what they've been paying for. But just to give an analogy, most of the cars can easily run 150 kilometers an hour and definitely safer than the cars we had 30 years ago. But if you drive 150 on a free highway, that's one thing. If you try to run 120 with no distance, just like in some countries, that would be definitely a different thing. So be careful of road conditions, be careful of your process. Last point, manage your wet end is something that we always try to recommend. This is one of the bridges that we've been always trying to have with our branch in instrumentation, because we know that you can get the best benefits of your paper quality on your tonnage, on your economic impact and final revenue when you control at best your wet end, because if you start to control at the end of the cycle, you will not get the best of it. If you want to know more about this study, if you want to dig into this, if you would like to have more information about that, that's very static presentation, not as fancy as the Chelly one, but still we'll try to make improvements around the commodities, just like the ceramic blade. So you can find us at booth 115. Thank you for your attention. Grazie a tutti.